In this video, we take a quick look at what are called determinants. This is a pre-idea, to finding eigenvalues and eigenvectors. Okay, so I just want to talk about in this video, vectors. Just want to talk about the determinant all by itself in this video. Okay. So we're going to consider the determinant through the system of equations. Okay, and consider the system of equations ax equal, let's use a better letter here. Let's use a capital Y is equal to 0. Okay, where A is the matrix, say 3, 2, 3, 8, right? And the vector y is little x, little y. And 0, what we mean by that is the 0 vector. So if you're looking at this system of equations in matrix form, right, you can also expand it to be 3x plus 2y equal to 0 and 3x plus 8y equal to 0. So here's the system of equations, the same thing as a y equal to 0. Okay? Now consider solving this system of equations, right? You could take the second equation, multiply it by -1, and then add the two results together, which would give you -6y is equal to 0, which would imply that y is equal to 0. You could then take that y equals 0, back substitute it into the first equation to get 3x plus 0 equals 0, which also implies that x is equal to 0. Okay? So the thing that we should observe here is note that the only solution to the system of equations ay is equal to 0 is the 0 vector. Right? This was our x is equal to 0, and the y that we got here is the y. Right? So the only solution that we got to that system of equations was the 0 vector. Okay? The reason that is happening, or an equivalent set of consequences, is that the matrix A, we knew by looking at the matrix A that it was 3, 2, 3, 8. Right? That if you do what's called taking the determinant of this matrix A, det capital A, which is essentially just doing the product of the diagonal elements, 3 times 8, and subtracting the product that is on the off diagonal, so minus 3 times 2. So you get 24 minus 6, which is, that's 18, but the most important thing is that it is non-zero. Okay? So the fact that you had a non-zero determinant was what was an indicator of the solution only to that system of equations only having the 0 solution. So when you're looking at a system of equations ay equal to 0, and the determinant of the matrix that's there is not equal to 0, then the only solution to ay equals 0 is y is equal to 0. This is a very important result, which tells us about how the determinant and systems of equations are related to each other. So, maybe consider a consequence, consider another example where the determinant is not where it is equal to 0. So consider maybe the system of equations 2x plus 4y equal to 0 and 4x plus 8y equal to 0. Okay? Which means that this is a system of equations ay is equal to 0, where the matrix A is 2, 4, 4, 8, and capital Y is little x little y. Notice that in this case, the determinant of this matrix A is 16 minus 16, which is equal to 0. The fact that the determinant is equal to 0 indicates that there's going to be, indicates that there will be non-zero solutions to AY is equal to 0. Okay? And you can see that here in this case, that if you try to solve this system of equations, right, something weird or interesting is going to happen in the sense that you can multiply both of these equations by -2 to get -4x plus 8y equal to 0. You could add that to the second equation, right, to get 16y is equal to, multiply by negative, right, and then that led to 0x plus 0y equal to 0, which meant that, for example, x could be equal to anything, right, which would indicate that 4y would be equal to -2x, y would be -1/2 x, and therefore another answer to the system of equations would be y is equal to, x could be anything, and y would be -1/2 of that anything. Okay? You'll notice that, well, never mind. So what we have here is that any multiple of the 1, -1/2 vector is a solution to AY is equal to 0. The fact that this was not equal to the 0 solution was an indicator of the determinant coming out to be 0. So if the determinant comes out to be 0, you can look for you can expect to have non-zero solutions to AY is equal to 0. Okay? So that's a precursor to the concept of the determinant and how it's going to eventually be used to find the eigenvalues and eigenvectors of a matrix.